Hi everyone, good evening everyone. My name is Renji Thomas and I am going to teach you class 12 chemistry today. So I have a lot of plans for you all who are sitting at home idle during the lockdown period. I plan to fill my YouTube channels with a lot of educational videos on the physics, chemistry and mathematics. So today I am going to start a lecture on a topic that is solid state. Solid state, as you can see, it is the very first unit in chemistry class 12 and it carries 4 marks. So let's get started. So if you have any doubts, kindly kindly subscribe to my YouTube channel. If you go to YouTube and search Renji Thomas, you'll get my channel. Kindly subscribe and like my videos so that I'll get more motivation to make more such videos. So this is my first video on chemistry class 12. So as I informed, it's of 4 marks. So let's begin with what is a solid state. So guys, what you see on the board, you see the Rocky Mountains, hills, glaciers, and you see the sandy beaches. What are these? If I ask you the question, your answer will be these are all what? Solids. As simple as that. Then over to the next slide, you can see some more interesting things, some more interesting pictures of facets like these are solids, as I have already told. In the next slide, what you see all of you see rivers, you see lakes, you see seas, and you see oceans. What are these? Any answers? These are liquids. So now the atmosphere, as you know, is made up of a lot of gases, right? And air is made up of nitrogen, oxygen, and many other gases, right? Nitrogen and oxygen are mostly present in air. We know that 78% and 21% respectively. Rest are neon, argon, and other gases. So solids are more common in the universe. Okay, if you look at the periodic table, the solids are more dominant than liquids or gases, right? So if you look at a periodic table over here, you can see that most of the elements in the periodic table, most of the elements are your solids, right? Very few gases and very few liquids are present inside the Earth's crust. So this makes the case strong case for studying more about the solids in details. So as a part of that, it is very important to study the structure of the solids. So for that, we begin this chapter. So, what are the properties of solids? Right? So you know that properties solids are hard, they are rigid, they have got a definite shape, size, etc. But the main properties of solids, they depend upon the nature of what? Number one, the nature of their constituent particles, right? And number two, the force of attraction that exists between the different constituent elements or ions or atoms present inside the solid. So these two facets are responsible to make a solid, right? What are the two facets? The constituent particles, there may be atoms, there may be ions, or there may be elements, and the second one is the binding forces, the force of attraction that exists between the molecules, atoms, or ions present inside the solid. So these are two important points that needs to be kept in your mind. Now, what is the distinction? Okay, what is the distinction between a solid, liquid, and a gas? If you look at this animation over here, you see gases and liquids are there, and then you see another one. What is that? Solids are there. So, what's the difference between these gases and liquids when you compare it to the solids? Right? There is some common feature to gases and liquids. What is a common feature? The common feature to gases or liquids, if anyone can answer this by looking at the presentation over here or video over here, the common thing that is gases and liquids are known to possess fluidity. They have got the ability to flow more freely, right? And solids are considered to be more rigid, right? They have a property of rigidity. What is rigidity? Rigidity means something that is so hard that its configuration cannot be altered or changed, or a substance that retains its original shape or size after the deforming force has been removed from that substance, right? Like for example, this luster. if it's so hard, I try to bend it as much as possible, but it does not break. Maybe there is some deformation that occurred in this cluster, but it's not so visible. That means we say that the deformation is little or almost negligible. So we say this object is a rigid body. So solids are considered to be more rigid, while gases and liquids are considered to possess a property of what? Fluidity, right? I hope you understood this, all of you who are watching this video. Now, why do liquids, gases possess fluidity? Why solids possess rigidity, right? That is a very interesting thing that comes to your mind. Why solids are considered to be rigid? Why liquids or gases are considered to be more fluidity or less rigid? So this can be explained on the basis of two important things, right? So I'll come to that as we go on more into the video or the presentation over here. So you can see that in the animation, you can see that the gases, in the constituent particles inside the gas, they are more free. They are more free to move here from one place to another place. They are free to move, right? Like now you have the lockdown period. You are not free to move here and there. Of course, this is not a curfew-like situation. You can go and buy your items from grocery and all, but there's a restriction that is imposed. Up to 2 p.m. you are supposed to buy everything and come back to your homes, right? So there is not so free movement, right? So, but that is the case of the solids. There's not so free movement, right? But in case of liquids and gas, they're free to move, right? So in solids, how do they move? They only oscillate to and fro about their what position? About their mean position, right? Or their about their mean position, they oscillate to and fro, right? You can see in the slide. Now, there are three categories of matter, right? There are three categories of matter. One is your solids, liquids, and gas. Okay. Now, whether a substance will exist as a solid, or whether a substance will exist as a liquid, or whether a substance will exist as a gas, it depends upon two main factors. Let's discuss that one by one. दो factors हैं जो decide करता है कि solid की तरह exist करेंगे या liquid की तरह exist करेंगे या gas की तरह exist करेंगे. उस तीन factors को हम इस वीडियो में पढ़ेंगे या इस lecture में पढ़ेंगे. So these are the two opposing factors. So they are opposing each other. The first one is the interparticle attractive force or the intermolecular force of attraction. And the second one, as I just skipped that slide over a little bit, the second one is the thermal energy. What is thermal energy? If anybody asks you, thermal, the word thermal comes from the word therm. Therm is heat. So when you heat a substance, the molecules inside the substance start moving here and there. So that is the cause of motion is due to the heat that is being supplied to the substance. So that energy possessed by a molecule, by a substance, when molecules of the substance, when it is being subjected to heat, right? That is called the thermal energy. So these two facets are very important to understand. So let's move on to the next animation. So what is the first one? Interparticle attractive force. When I talk about the interparticle attractive force, think of a solid having atoms or molecules aligned in a particular fashion. So what does these particles do to each other? These particles, they exert force on each other, right? They exert force on each other, as a result of which they come more close to each other. This can be assumed to as a spring mass system. When you have a mass and you have spring attached to that mass, what does it do? When you try to pull that mass over to one side, as you release the mass, what will happen? The spring tries to come pull it back to its original position. So that is what is happening here. What is interparticle attractive force? This is nothing but there is a force of attraction that exists between the molecules present inside a solid, liquid, or gas. I hope you have understood up to here. So you can see in this slide that every molecule or atom or ion, they are exerting force on every other molecule, as a result of which they come more and more closer to each other. You can see there. So that is what is happening mostly in case of solids, right? Now, what is thermal energy? As I've told you, thermal, the word thermal comes from the word therm. Therm is heat. So whenever you have any substance that comprises of molecules. Of course, every substance comprises of molecules, atoms, and ions. What is happening? They are moving to and fro. But you can see that as the temperature is increasing, the motion becomes more and more rapid, more and more fast. Right? So temperature has got a direct relationship to the kinetic energy of the molecules. Right? As the temperature is increasing, the average kinetic energy of the molecules present inside the substance is increasing. That's as a result of the energy. What is that energy? Thermal energy. So thermal energy is, we can say, thermal energy is directly proportional. Thermal energy is directly proportional to the what? Average kinetic energy of the molecules present inside the substance. More the thermal energy, more will be the average kinetic energy. So we can say kinetic energy is directly proportional to the temperature. So you can see the example of a solid or inside a gas. Inside a gas. What is that? The molecules are moving too rapid, too fast, to and fro, right? As the thermal energy is increased, right? As the thermal energy inside a gas container is increased, the molecules are moving faster, right? That means there is less attractive force exists between the molecules inside a gas. That's why we say that the thermal energy is more in case of thermal energy is dominant, right? And the intermolecular force of attraction is less dominant when it comes to a gas. But as you see in the liquid, what is happening? The intermolecular force of attraction is more dominant, while thermal energy is less dominant. That means the liquid molecules cling more closer to each other. The movement is restricted to some extent, right? Then when you look about in case of the solid in the next slide, in case of solid, what you see is that the intermolecular attractive force will be very much dominant, right? We can come to the next slide and you can see that in case of solid, what will happen? They cling more close to each other because the intermolecular force of attraction dominates the thermal energy, right? So thermal energy does not have much effect on the intermolecular force of attraction. It is a dominating factor. So that's why we say the solids are more rigid, okay, compared to liquids or gas. Or we can say the liquids gas causes the property of fluidity. I hope you understood this. I hope everyone is clear. If you have any doubts, you can ask me in the comment section in the YouTube channel. Now, let us go to the next slide. You can see this solids, it's more close pattern. Now, the classification of solids, right? So, solids जो है उसको तीन प्रकार का क्लासिफिकेशन होता है. एक आपका क्रिस्टलाइन सॉलिड होता है और एक आपका पॉलीक्रिस्टलाइन और एक अमरफस. तो बेसिकली हम लोग इस वीडियो में आज सिर्फ क्रिस्टलाइन और अमरफस का बारे में पढ़ेंगे, जो कि आपका एमपीएससी और सीबीएसई पॉइंट ऑफ व्यू बहुत इंपॉर्टेंट क्वेश्चंस है. आता है एग्जाम में, व्हाट इज द डिफरेंस बिटवीन क्रिस्टलाइन एंड अमरफस सॉलिड. So let's study about the classification of solid. What you see all of you on the board, you see diamond and glass. What are those? These are solid.